Hi there, welcome to my channel Mandu to Fundu. In this video, I am going to discuss about the solution for finding the container with most water problem. Let's look at the problem description. We are given an integer array height with n number of elements, and each element in that array gives the length of the vertical lines that we can draw from the x-axis. So the endpoints with that data, the endpoints will be like I comma 0 and I comma the height of I. For example, the endpoint for the element 8 will be 1 comma 0 and 1 comma 8. We have to find out two vertical line which can form a container along with the x-axis and can hold the max amount of water and return that max amount. Let's look at this input. This line and this line along with the x-axis form the container with the maximum capacity, which is 49. Let's see how we can solve this problem using two-pointer approach. So we have this input height array which has 9 elements, and each element contains the height of each line, vertical line, and the expected output is 49. So first the max area is set to 0, and then the left pointer point to the beginning of an array and the right pointer points to the end of an array. Each iteration we compare the area formed by these two vertical lines and then compare that with the max area. When we compute the height of the current container, we have to compare the height value pointed by the left index and the right index and choose the minimum value. So in this case 1. If we choose the higher height value as the current container's height, then the water will overflow through the side with the lower height. First we compute the height of the current container by comparing the height pointed by the left and right pointer and choose the minimum value. So in this case we compare 1 and 7 and 1 is lesser, so we set the height 1 as height. Then we compute the width by finding the difference between the left and the right pointer, which is 8. Then we compute the area, which is 8, and then we compare that with the max area. So the current area is greater than the max area, so we update the max area. So we repeat this until the left and right pointer meets, then finally we get the max area. Let's look at the flowchart. Input for this procedure is the height array. First we initialize the left and right pointer to point to the beginning and end of the array, and then we initialize the max area to 0. Then we check whether the left pointer is less than the right pointer. If it is true, then we enter the loop. Otherwise we break out of the loop and return the max area. So inside the loop, first we compute the height by choosing the minimum value between the height pointed by the left and right pointers. Next, compute the width by finding the difference between the left and right indexes. Then compute the area. Next we check whether the current area is greater than the max area. If so, we update the max area. Otherwise we proceed. Then we check whether the height pointed by the left is less than the height pointed by the right. Then we increment the left pointer, otherwise we decrement the right pointer. We repeat this until the left and right pointer meets. Finally we break out of the loop and then return the max area. Let's move on to coding. First I initialize the left and right pointer so that they point to the first and last element of an array, and then initialize the max area to 0. This for loop runs until the left and right pointer meets. First, I compute the current height by choosing the minimum value of the height pointed by the left pointer and the height pointed by the right pointer. Next, I find the width by computing the difference between the right and left pointer. And then the current area is computed using the height and the width. So if the current area is greater than the max area, then we update the max area with that current area value. And then if the height pointed by the left pointer is less than the height pointed by the right pointer, then we increment the left pointer. Otherwise, we decrement the right pointer. Finally, we return the max area. Now I am going to run the test cases. Okay, it's accepted. Now I'm going to submit this program. Cool, it's accepted. Next, I'm going to do the code walkthrough with sample input. We have this input array height with 9 elements and the expected output is 49. First, we initialize the left pointer to 0 and the right pointer to 8, last element, and the max area to 0. So in the iteration 0, we compare the height pointed by the left and the height pointed by the right. And then choose the minimum value. Next, compute the width by subtracting the left and right index, and then which is 8 now, and then compute the area 8. And now we compare that value with the max area 0. So current area is greater, so we set the max area to 8. And then we compare the left and the height pointed by the left and the height pointed by right. Whichever is less, we advance the pointer. So we advance the left pointer. Now left is pointing to 2 and the right stays there. So now we choose the minimum value between those two values, which is 7, and then the current width is difference between 8 minus and the index 1, which is 7. So the area is 49, and we compare that with the max area. So the current area is greater, 49, so we assign that to max area. Next, we compare the height pointed by the left and right pointer. The height pointed by the right is lesser, so we advance the right pointer. Next, I compare the heights pointed by left and right, and value 3 is less, so we choose that value as the current height, and then the width will be the difference between the right and left pointer, and the product is 18, which is less than the max area, so we are not updating the max area this time. And we compare the heights, whichever is less, we advance the pointer. In this case, the right pointer is advanced to 8. Now we compare the heights and choose the height as 8, and then the width will be difference between left and right, so that is 5. Then the area computed will be 40, which is also less than the max area, so we are not updating the max area. And then because both the values are same, I advance the left pointer and I repeat that process, comparing the heights, and choose the lesser value, so in this case 6, and then the width will be 4, difference between the left and right, the area is 24, which is also less than 49, so we are not updating the max area. Then we choose the lesser value. In this time it is pointed by left, so we are advancing the left pointer. Now it is pointing to 2. So in the iteration 5, the current height is 2 and current width is 3 and the area is 6, which is less than max area computed so far. So we are not updating the max area. And then we advance the pointer from the lowest element, lowest height, and now it is pointing to 5. So the lower value is 5 and the width is 2 and the area is 10, which is also less than 49. So we are not updating it. And now we are comparing the heights 5 and 8. So 5 is less, so I advance the left pointer. Now it is pointing to 4. So the current height will be the minimum of the 4 and 8, so which is 4, and the width is 1. So the current area is 4. So the max area is this, which is less than the max area computed so far. So we are not updating it. In the next iteration, both the left and right pointer meets, so we break out of the loop and we return the max area 49. Next, I am going to do the time and space complexity analysis for this solution. Let's take this input with 9 elements for our analysis. How many iterations this for loop performs inside the max area function? For this input, it performs 8 iterations. It runs for n minus 1 times for the input of size n. And depending on the nature of the input, the left and right pointer advances faster or slower. So the overall time complexity is order of n. With respect to the space complexity, we use only few variables in this function. We are not allocating any space with respect to the input size. So space complexity is order of 1. Thank you for watching this video. Have a great day.